Hi, welcome to Unit 6A, Day 3. Today we're going to look at our first of two special right triangles. It's called a 45-45 90-degree triangle. So the first thing we're going to do is figure out where do these triangles come from. If I look here, it says to sketch one diagonal in each square below, then mark all the angles with the appropriate degrees. So if I draw on my picture and I draw in one diagonal, then it says to mark all the angles with the appropriate degrees. Well, I know that my corners, since it's a square, have 90 degrees. And I know that since in a square, all my sides are exactly the same, and we talked about that hinge theorem, that if you have things that are open the same amount, right, then they're going to open to the same size on the opposite side. So I know that this angle is going to open to this side here, which is going to match the opposite side over here. So these two angles have to be the same. And then the same thing's going to happen here. So what's going to end up, that diagonal, is going to end up dividing these into equal parts. So I know if that whole corner is 90, because it's a square, which is a rectangle, then each of these sides have to be 45 degrees. 45 degrees here, 45 here, 45 degrees here, and 45 degrees here. Okay, it does say to do one in each square below. So when I go and look at the second square, let's say I put my diagonal here. Same thing, I know I'm going to have 90 degrees. And then we'll be able to show or prove that each of these angles is going to have to be 45 degrees. Okay, so when you draw a diagonal in a square, you end up with two congruent right triangles with the angles that are going to measure 45 degrees, 45 degrees, and 90 degrees. Okay, and when you look at the square, you know you're going to have two sides here that are going to be the same, and then you're going to have the hypotenuse, which will of course be longer than these two sides. Okay, so you're going to have a leg here that's going to be exactly equal to the leg here. So what's kind of neat is when we do the Pythagorean theorem, if I take my leg squared and my leg squared, those are exactly the same value. So if we say one has a value of x, the other is also going to have a value of x. So I can say that I could do x squared plus x squared. If I square root that, that's going to give me the hypotenuse. Okay, x squared plus x squared, we could rewrite that as 2x squared is going to be my hypotenuse. Okay, now remember, you can't square root individually when you're adding or when you're subtracting, but it is kind of neat that that does work when you are multiplying. So when I'm multiplying, this is really the square root of 2 times the square root of x squared. That I can split to be my hypotenuse. Okay? So then the square root of 2, that's going to be some ugly long decimal that we don't want to have to deal with. But this x squared that's being square rooted, we already know that squares and square roots cancel each other out. So this really becomes the square root of 2 times just an x equals the hypotenuse. And when we have square roots of 2 times a variable or times any number that's not inside the square root, the order we write them in, there's always an order we write them in. Like if I'm doing x times 3, I'm going to write that as 3x. The number would come first. Anytime you have a square root, you're going to write that last. So really the way I would write this is I would say x square roots of 2 is going to be my hypotenuse. So if my legs are both the same, they're both x, and they have to be the same, right? Because they come from the sides of the square. So my legs have to both be the same every single time. The legs will be equal or congruent or the same every single time. And then your hypotenuse is going to be whatever that leg was. Remember, we said the leg was x. It's going to be whatever that leg was times the square root of 2. Okay, so in the next video, we're going to go ahead and look and see how we can apply this information, our legs being a value of x, and our hypotenuse being the value of x square root of 2, to be able to quickly figure out how long each of our sides are on a 45 degree, 45 degree, 90 degree triangle. Okay, so come on back to see how to work that. Thanks for watching.